Hello and welcome to Doc Clay's chemistry lessons. Today we're going to be looking at amount of substance and gas volumes. So this is the third video about amount of substance. We've looked at reacting masses, concentration, titration calculations, and this is the third one on gas volumes. And by the end of this lesson you should be able to recall how to work out how many moles there are in a given gas at room temperature and 0 degrees Celsius, and also complete molar gas volume calculations. So we are going to do these calculations in exactly the same way that we have done both the reacting mass calculations and the titration calculations, but we're going to use our equation here for gas volumes, which is slightly different. Because there's a lot of space between all gas molecules, we can assume that all gases occupy the same volume. So that would mean that a 1 mole of gas is going to occupy the same volume of gas at any other substance. So this is the same for all gases at room temperature. And what we say, or what we find out, is that the volume of any gas in decimeters cubed is equal to the moles of that gas multiplied by 24. That's if we're dealing with things in decimeters cubed. If we're actually wanting to do that with centimeters cubed, or if we're asked to find out things in centimeters cubed, then we would have to multiply our answer by 1000. So there is our conversion. If we want to go from decimeters cubed to centimeters cubed, we multiply by 1000. If you like your equation triangles, then we can do an equation triangle for you. We have moles on the bottom, multiplied by 24, and at the top here we have volume. Remember, importantly, this is going to be in decimeters cubed, and we can have an equation triangle. Use this idea in exactly the same way as we've used for titration and reacting mass calculations. We're going to write out balanced equations, work out the moles of known, calculate the moles of an unknown using the mole ratio, and then calculate the mass of unknown. But in this case, we're going to calculate the volume of the unknown. So I'm just going to change that here to volume of unknown. So without any further ado, let's have a look at an example. In this question, we're asked what volume of hydrogen, which is a gas, is needed to react with 40 grams of copper oxide. So we've got step 1 done for us here. We've got the balanced equation. The second step is now to calculate the moles of copper oxide, which, if you can remember from our previous lessons, is equal to the mass divided by the MR. So in this question, we've got 40 grams of divided here by the MR of copper oxide, which is 63.5 plus 16, which comes out at 79.5. We put that into our calculator. This 0.503 mole of copper oxide. Here we got a 1:1 ratio of copper oxide to hydrogen. So therefore the moles of copper oxide is equal to the moles of hydrogen, which is equal to 0.503 mole, and therefore the volume of hydrogen gas is equal to 0.503 multiplied by 24, giving us 12.08 decimeters cubed of hydrogen gas, or 12,000 centimeters cubed of hydrogen gas. Okay, so you should now be able to recall how to work out how many moles there are in a given gas at room temperature and 0 degrees Celsius, and complete the molar gas volume calculations. Just realize that the only difference here between the room temperature and 0 degrees Celsius is at room temperature we multiply here by 24, but at 0 degrees Celsius this number here becomes 22.4 at 0 degrees Celsius.